Today's goal was simple. Figure out a way to thoroughly test Deepseek's reasoning capabilities. But one thing led to another, and before I knew it, I ended up with this monstrosity. It's designed to act as a substitute for ChatGPT, and it works well enough that I think it actually justifies using Comfy as a chatbot or even as a research tool. Before we start, please like and subscribe. It helps me make sense of what I'm doing. Here's the idea. This workflow is kind of like Perplexity. Kind of being the operative word here. It has the ability to connect to the internet for more recent results. If you look at the left side of the workflow, I've listed a few features that are up and running. Let's break those down. First, there's memory. This means it can retain chat history. Whatever conversation you've had up to that point stays in context, which is super useful. Then there's internet access, which allows it to pull in up-to-date knowledge. Perfect for keeping things current. It can also handle image generation, so you can generate images using Flux or any other image generation model you prefer. There's VLM capability too. This lets you upload an image and either describe it using a vision model or use the image in any way the workflow supports. Finally, you can add personas. These are essentially like GPTs that follow specific instructions, giving you different styles of responses or use cases depending on what you need. That's what it can do right now. But there are a couple of limitations I should point out. At the moment, it doesn't support RAG or audio uploads. Those features aren't available yet, but it's a starting point. Let's go through what the workflow consists of before diving into Deepseek R1 in Comfy and how this Frankenstein of a workflow compares to other similar tools. The workflow has two main parts, but it's flexible enough to expand into just about anything you need. The first part is what I'm calling the knowledge base group. The second part is the text-to-image group. We're starting with the knowledge base group since it's the one you'll likely use the most. I should mention up front, I'm terrible at naming things. Usually, I design my workflows to go from left to right, but this time I thought it made more sense to place the main tools in the center, with secondary tools on the right and left. At the very center of the group, you'll see the main nodes. Let's go through them from the bottom up. At the bottom, there's the audio preview node. This is where you can listen to an audio preview of any generated reply. Moving up, there are three key nodes in a row. The first is the model select node, where you'll choose the large language model you want to use. Next is the searxNG node, which provides access to the internet. We'll go over how to install and set up searxNG later. It's actually a lot simpler than I expected. The third node in that row is the persona node. Think of this as being similar to ChatGPT's custom GPTs. For example, I created a persona called Flux Dev Prompter that helps generate better image generation prompts. I'm also using another persona called GPT Dan for everything else. We'll cover how to create your own later. Above those nodes, you'll see the prompt input or query box. This is where you type your question or request. Directly above that is the reply box, where all the responses will appear. Moving up further, there's the chat history section. This keeps track of your conversation, so you can refer back to previous messages. Next to it, there's the LLM settings group. This section includes the API general link and extra model parameters. Everything in the workflow connects to, or from the general link, which we'll look at more closely later. Below all of that, you'll see three switches. These allow you to turn audio, image generation, and image uploads on or off, depending on what you need at the moment. Next to the switches, on the left, there's the image upload group. Right below that is the Kokoro TTs node. I initially had problems installing it. We'll go through some solutions later. Finally, over on the far right, there's the image preview. This is where you'll see the results of your image generation. That's basically it for this group. Below it, there's a basic text-to-image group set up for Flux. But we'll circle back to that in more detail later. Back to why we're here in the first place. Deepseek R1. This is a new AI model that's generating a lot of excitement because it reasons by working through problems step by step. For this setup, I'll be using a smaller, more efficient version of R1 called a distilled model. These models are optimized versions of the original that keep most of the reasoning power, but are designed to run on less powerful hardware. To run this workflow, I'm using Ollama as the backend for Deepseek, but I've made a few tweaks. Plus the version of Deepseek I'm using is called MFDoom Deepseek R1 tool calling, because it can use external tools as input. One major change I made was increasing the context length of the model. By default, Ollama's models have a context length of 2048, which really isn't practical for longer outputs. I'll show you exactly how to increase that context length later. For now, let's get the workflow started and test it out. I'm going to feed Deepseek a list of queries to see how well it performs, and I'll test it alongside the other nodes in the workflow to evaluate its overall functionality. But before jumping into the tests, let's take care of some setup steps. The API link is where everything happens, so I'll start there. First, I'm adjusting the temperature setting to 0.3. The ideal temperature range for Deepseek is usually between 0.5 and 0.7, but for this test, I'm going with 0.3. I'll also enable the memory and the main brain settings. Next, I'm setting the max length to 8000. The model's maximum context size is 8192, so this setting keeps us safely within that range. I'm leaving everything else at the default values, and I'll double check that its enable is set to true. For the system prompt, I'm removing the custom system prompt, which means the model will rely on its default system prompt from Ollama. As for the extra parameters, I've set top P to 1 and top K to 50. Anything below 50 seems to trigger an error, so it's important to keep that in mind if you're setting this up yourself. Most of the switches are turned off for this test, but I'm keeping the generate audio option on because I want to hear the audio output during testing. The model I'm using is the MFDoom Deepseek R1 tool calling custom model. This is the one I increased to a context length of 8192. Don't worry, I'll show you exactly how to extend the context length and how to make the models appear automatically in the model loader. For this initial round of testing, the internet search tool will stay off. We'll cover how to set that up later. The persona tool is also off for now. I've collected questions from all over the internet to test the model. These questions are designed to push its strengths in reasoning, math, coding, and general knowledge. The idea here is to see how well it performs across different types of challenges. To start, I'm going to ask the model to solve a classic logic problem. The question goes like this. A man is trying to cross a river with a wolf, a goat, and a cabbage. He can only take one item at a time across the river, but he can't leave the wolf with the goat or the goat with the cabbage unattended. How can he get everything across the river safely? It took a little while for the model to start generating an answer, but let's listen to what it came up with.
Think first, I need to identify the constraints. The man must transport the wolf, goat, and cabbage across the river one item at a time without leaving the wolf alone with the goat or the goat alone with the cabbage. To solve this, I'll start by taking the goat across first because it's essential for protecting the cabbage from the wolf. Then, I'll return alone to the starting side. Next, I'll take either the wolf or the cabbage over. If I take the wolf, I must bring the goat back to prevent the wolf from attacking the goat on the other side. This leaves me with the goat and cabbage together, which is safe since the goat won't harm the cabbage. After that, I'll take the cabbage across alone. Now, all items are safely on the other side except for the goat, so I can return to retrieve it. Finally, I'll make the last trip by taking the goat back to complete the process without any risks.
You can clearly see the chain of thought. But those asterisks are way too much. Let me add a text replace node above the reply. I'll add 1 asterisk in the first find field and 2 asterisks in the second find field. This will auto-remove all the asterisks in all the replies, hopefully making the audio playbacks a bit smoother. Next, I'll ask the model to explain its reasoning process for solving problems. I want to test its chain of thought capabilities. I'll use, show your reasoning steps to solve this math problem. If a is bigger than 1, then what is the sum of the real solutions of a minus a plus x equals x squared? Let's have a listen.
Alright, so I have this math problem here. If a 1, then what is the sum of the real solutions of a plus x equals x2? Okay, let me try to figure this out step by step. First off, let's look at the equation they gave, a minus a plus x equals x squared. So that would be written as a plus x equals x2. Wait a second, if I simplify the left side first, right? Because a is 0. So 0 plus x is just x, so then the equation simplifies to x equals x2. Okay, so now we have x equals x squared. That seems simpler. Now let's rearrange this equation to bring all terms to one side because it looks like a quadratic equation. So subtracting x from both sides gives us 0 equals x2x, or, flipping that around for clarity, x2x equals 0. Alright, so now we have a quadratic equation. X squared minus x equals 0. Quadratic equations can usually be solved by factoring or using the quadratic formula, but since this one looks factorable, let me try factoring first. Looking at x2x, I notice that both terms have an x in common, so I can factor out an x. x1 equals 0. Perfect. Now, according to the zero product property, if the product of two factors is 0, then at least one of the factors must be 0. So we set each factor equal to 0 and solve for x.
Reasoning for problem solving seems to work just fine. I'm going to follow up with a related prompt to get more insight into its problem solving methods. I'll ask, explain your method for solving math problems and point out areas where you could improve. This should just continue where we left off since memory is enabled. Let's hear the reply.
Think all right. So I need to explain my method for solving math problems and also point out areas where I could improve. Okay, let's start by thinking about how I usually approach math problems. First off, when faced with a new problem, I try to understand what it's asking. I read the problem carefully and make sure I know all the parts of it. If there are any terms or concepts I'm not familiar with, I try to break them down or look for examples that might help me grasp their meaning. Once I have a good understanding of what the problem is asking, I start by writing down everything I know related to the topic. This helps me organize my thoughts and identify any formulas, theorems, or strategies that might be useful in solving it. For example, if it's an algebra problem involving quadratic equations, I'll write down the standard form of a quadratic equation and note any relevant properties or solution methods. Next, I try to devise a plan or strategy for tackling the problem. This could involve choosing the right approach among several options, like substitution, elimination, graphing, or using specific formulas. Sometimes problems can be solved in multiple ways, so it's good to consider different methods and pick the one that seems most efficient. After planning my approach, I proceed step by step, carefully executing each part of my strategy. It's important to work methodically to avoid mistakes and ensure that each step logically follows from the previous one.
Let's move on to troubleshooting. I want to see how well Deepseek handles specific errors in ComfyUI. Let's try the following. What can you tell me about this error, and how might I solve it? I'll paste the error I got when I installed and used Kokoro for the first time.
Think all right, so I'm trying to figure out what this error means and how I can fix it. The error message says there's a type error because a none-type object isn't subscriptable. That sounds like something is returning none where we're trying to access an index or attribute. Looking at the traceback, it starts in execution pi at line 327, then goes to line 202, and finally to line 163 in nodes pi. It mentions getting an object with a subscript that's not allowed. Maybe there's a function expecting an argument but isn't getting one, so it returns none. I should check where the error is happening. In the traceback, it points to line 174 in execution pi, which calls process inputs, and then appends a result using getEtter, obj func. If obj or func is none here, that would cause an error because you can't subscript none type. Perhaps there's a missing argument being passed somewhere, causing a variable to be none when it expects a value.
This would throw me into a very unpleasant rabbit hole if I already didn't know what the solution was. I'm also curious about its ability to handle creative tasks. For example, I'll ask it to write a short story about a man who wakes up in the future not knowing where he is. I changed the location of the text replace node to port directly to the Kokoro node. Let's listen to the output.
Title: The Enigma of Existence by Sarah, Chapter 1. The awakening Sarah, a young and curious individual, had always been fascinated by the mysteries of existence. One evening after finishing her work, she decided to explore beyond the familiar boundaries of her house. As she walked through the bustling city streets under the bright neon lights, she encountered a strange phenomenon. The streetlights flickered and changed color unpredictably, and suddenly, Sarah found herself standing in an unfamiliar part of town at midnight. She tried to navigate using her phone's GPS, but was met with an error message, unknown location. She couldn't figure out where she was or how to get back home. Panicking slightly, she called a friend for help. Chapter 2.
It's not bad at all. It at least did not reason its way through the story. There's one last feature I want to test, and that's its ability to use a search tool I'll enable the searxNG search tool and ask, find information about the AI Stargate project announced by President Trump, what it plans to achieve and who the people are that's in charge of it. Then summarize it.
All right, I need to help the user find information about President Trump's AI Stargate project. They want a summary of what it plans to achieve and who is in charge. First, looking at the provided snippets, multiple sources mention that Trump announced a $500 billion joint venture called Stargate involving OpenAI, Oracle, SoftBank, and possibly others like Microsoft. The project aims to build AI infrastructure, with plans for data centers starting in Texas. Key players involved are Sam Altman from OpenAI, Masayoshi Son from SoftBank, Larry Ellison from Oracle, and possibly Elon Musk, as there were clashes mentioned.
The model seems to access the Internet. The first time I ran it, it told me about its cutoff date, but gave me the correct reply when I ran it a second time. This is amazing, a great model with internet connection without needing a costly API. Before wrapping up, there are a few things to keep in mind when querying Deepseek R1. It works best with zero-shot prompting, which means you should directly describe the problem in your user prompt without relying on system prompts. For math problems, it's a good idea to specify the output format, like saying, please reason step by step and put your final answer within brackets. Temperature settings also matter. Keeping the temperature between 0.5 and 0.7 helps avoid endless loops or incoherent responses. The model performs best in English and Chinese, but for other languages, results might not be as reliable. In some cases, it mixes English and Chinese in reasoning tasks, so that's something to watch out for. I plan to use Deepseek every day as part of my personal workflow, especially for quick problem solving and keeping my AI projects within ComfyUI. It's shaping up to be a valuable addition for managing my tasks efficiently. Next, let's go through each of the options in the workflow. For now, I'll leave Internet access on because I want to test it with a recent question. I'm also making sure the model is set to if doom Deepseek R1 and that the memory is enabled. I'll start by asking it something straightforward like, tell me about the recent Greater Los Angeles wildfires.
The recent wildfires in Greater Los Angeles are part of a complex environmental and human activity issue. Here's an organized summary of the situation. 1. Causes: climate change. The region has experienced extreme weather conditions, including high temperatures and low humidity, exacerbating fire risks. Human activity. Both intentional arson and unintentional fires contribute to the problem. 2. Impact: habitat disruption.
The responses are pretty solid so far. Next, I'll test the image upload feature. First, I'll activate the image upload option. I'm also going to deactivate the generate audio switch, since I won't need it for this part. I'll switch the model to Lava, but I'll also disable the search tool because Lava doesn't work with it, and I'll change the context length back to 2048. Once that's set up, I'll upload an image and ask it to describe the image and tell me what movie it's from. Let's see what it replies with. The image you've provided appears to be a promotional poster for the movie Avatar. It features two characters from the film, one with blue skin and the other with a more human appearance. They are standing in front of a waterfall, surrounded by lush greenery. This scene is likely set on Pandora, the fictional world depicted in the movie. The characters are dressed in traditional Na'vi attire, which includes intricate headdress and body adornments. The overall atmosphere suggests an idyllic and harmonious environment, contrasting with the more chaotic and destructive wildfires in Greater Los Angeles. The mix-up in the last line is because the memory is on. The model thinks that you're continuing the conversation. This shows that you can use different models interchangeably as long as the memory is on. If you want a new conversation, all you have to do is turn the memory off. Let's turn it off and try again. Let's see what it says. The image you've provided appears to be a digitally altered or Photoshop picture of two characters from the Avatar franchise. The characters are depicted with blue skin, which is characteristic of the Na'vi people in the film series. They are standing close to each other and seem to be engaged in conversation or interaction. The background suggests an environment similar to what one might find on Pandora, the fictional moon from the Avatar movies. This is more like it. The last thing I want to test is image generation. For this, I'll disable the image upload option and enable the generate image switch. I'll also activate the persona and change it to one I created myself, called Flux Dev Prompter. I'm going to keep the memory disabled, plus I'm going to change the model to Mistral, because I want a straightforward image description. The prompt I'm using here is, generate one cartoony, Pixar-style layered image description for the following. Frankenstein walking with his hand in front of him like a zombie towards the right sign. He's walking past two signs. The first sign points to the left and says Chat-GPT, while the second sign points to the right and says Deepseek. I'm using the Flux Dev model with wave speed at 25 steps and a guidance scale of 3.5. I'll change the resolution to cinematic view and the megapixels to 1. Let's give it a moment. Things might take longer than using something like Chat-GPT or Claude, especially if you're running it on a potato. Still, it's a pretty good alternative. Always try and see if you can't get something done in Comfy before running to other external tools. This is really a powerful tool once you get to know it. Let's talk about how to set everything up so you can get started. We'll go through it step by step. First, you need to install the necessary nodes. We'll start with Kokoro. Do not install it from the ComfyUI manager. I did that and kept getting a known type object is not subscriptable error. The node also kept trying to install NumPy 2.2. This completely messed up other nodes that required the older 1.25.2 version. So what I did is the following. Open the manager and click on Custom Node Manager. Type Kokoro and go down to the one that says ComfyUI-kokoroTTS and click on the name. It's the one by Benji. Do not click on Install. This will take you to the node's GitHub page. Click on the drop-down page next to Code and click on Download Zip. Save the zip to the Custom Nodes folder and extract it. Inside the extracted folder is another folder named ComfyUI-kokoroTTS main. Rename it to ComfyUI-kokoroTTS and move it to the Custom Nodes root folder. You can now delete the one that's named ComfyUI-kokoroTTS main. Open the ComfyUI-kokoroTTS folder and then the requirements file. There's 3 packages in the document. Change NumPy to NumPy equals 1.25.2. This forces Kokoro not to install NumPy 2.2. Save the document and navigate to ComfyUI embedded folder. Type cmd in the top Explorer bar and add the following in the terminal. python.exe -mpip install-r and the location of the requirements.txt file and press enter. When it's done, start ComfyUI again. Next, navigate back to the Python embed folder, open the lib folder and finally the site packages folder. You have to delete the folders that start with a tilde sign. Here are some examples. Delete them all. These are temp folders, unfinished packages from failed installs or updates that did not finish. Kokoro started working immediately as soon as I deleted them. Close Comfy and then start again by clicking on Run NVIDIA GPU.bat and it will have fixed the whole nontype object is not subscriptable error. This solution worked for me. Let me know if you have other errors in the description. I believe I can help you out with them. Kokoro needs 2 downloads, the model file and the voices. Click on the link in the description to go to the download page. Download both and put them in the models Kokoro TTS folder. Create the folder if it's not there. Next, drag the workflow into the workspace. If there are any missing models, open the ComfyUI manager and click Install Missing Custom Nodes. This will list any missing nodes, select them and click on Install. If you already have Flux installed, you're good to go. If not, there's a video up here with clear instructions on how to do it. Next, we need to edit the LLM Party Configuration file so that it detects Ollama automatically. Here's how you do that. Go to the Custom Nodes folder, then open the ComfyUI LLM Party folder. Scroll down until you find a file called config.ini. Right-click on it and choose Edit in Notepad. I'm using Notepad for this example, but any text editor will work. At the top of the file, you'll see a section for API keys. Next to OpenAI API key, add the word Ollama after the equals sign. Below that, there's a line for base URL. Add the following URL after the equals sign. I'll include the exact details in the video description for reference. Once you've made these changes, click File and Save. This ensures that Ollama models will be automatically detected by LLM Party. Next, let's set up the Internet access. Getting searxNG set up for Internet access might seem like a complicated process, but it's actually pretty straightforward, and we'll be using Docker to do it. Start by heading to the Docker website. I've included the link in the description below to make it easy for you. Once you're on the site, click on Download Docker Desktop and select the version that matches your computer. For my setup, I'll pick Windows AMD 64 version. Before we move forward, it's important to check if Windows Subsystem for Linux is installed on your computer. To do this, click on your Start button and type cmd to open the command prompt. Once you're there, type WSL and hit enter. If you see a response indicating WSL is not installed, type WSL-install and press enter to install it. After that, you'll need to enable WSL. Again, click on the Start menu, but this time search for Enable Windows Features and click on Turn Windows Features on or off. A window will pop up. Scroll through the list and check the box for Windows Subsystem for Linux, then click OK. Let the setup finish, but when it asks you to restart, choose Don't Restart for now. Next, we need to make sure virtualization is enabled on your computer. Open your Task Manager and go to the Performance tab. Under CPU, look for the word virtualization. If it says enabled, you're all set. If it's disabled, you'll need to enable it in your BIOS settings. There's plenty of videos on YouTube that walk you through that process if you're unsure how to do it. Let's install Docker. Find the .exe file you downloaded earlier and run it. When you reach the configuration step, there's an option to add a desktop shortcut. Check that box if you'd like a shortcut, then click OK to proceed. Once the installation is complete, Docker will ask you to close and log out. Allow it to log out. After you log back in, open Docker. You can do this by searching for it in your Start menu or double-clicking the desktop icon if you created a shortcut. The first time Docker launches, you'll see an option to accept the service agreement. Click on Accept. You can skip the login step and the survey. Sometimes you'll get the following error. Just restart your machine and then run Docker as administrator. Wait for Docker to finish initializing. Click on Images once the dashboard is ready and then search images to run. Type searchNG in the search bar and select the first one with 10 million downloads and click on Pull to retrieve the searchNG image. Once the installation is finished, click Run. Add a name for the container. I called mine my search, and the port is 8080, and then click on Run. To confirm that searchNG is running, open your browser and enter localhost 8080. Alternatively, you can check its status by opening command prompt and typing docker ps. If everything is set up correctly, you'll see searchNG running. With this, we've successfully added online search capabilities to your workflow. Just make sure Docker is open with searchNG running in the background. Next, let's set up Ollama. Ollama is a powerful tool, but there's a common issue we need to address. Its models come with a limited context window, often set at 2048 by default. That limitation can cause problems when you're working with long text inputs or coding tasks. If your input is too long, the model might cut it off. On top of that, if the output tokens aren't configured correctly, you could end up with summaries that get truncated. The good news is you can adjust the context length, and I'll walk you through exactly how to do that, starting with installing Ollama. First, head to the Ollama website. There's a link in the description below that'll take you straight there. Once you're on the site, click the download button, then choose the Windows version. After the download is finished, double-click the exe to start the installation. Click on Install and wait for the installation to finish up. The installer will take care of everything, and once it's done, Ollama will automatically run in the background. The next step is to open the command prompt. You can do that by clicking on the Start menu, typing cmd into the search bar, and clicking on it from the results. This will open a terminal window where we'll input a few commands. Go back to the Ollama website and search for the model called Deepseek and then enter. Once you've found the version of Deepseek R1 you want, click on it to open its page. Mine is MF-Doom with tool calling. You'll see a drop-down menu where you can select the version you want. For this walkthrough, I'm choosing the 7B version. Copy the command provided on the page and paste it to the terminal. Before running, replace the word run with pull. Because we're only downloading the model right now, press enter. The model will start downloading, and this part may take a little while, depending on your internet speed. Once the download is complete, type Ollama list into the terminal and hit enter. This will display all the models installed on your system, including Deepseek. From here, we'll work on adjusting the context length. Changing the context length is straightforward, but figuring out the right value for your setup takes a little trial and error. Start by checking if the context length is still set to the default 2048 or if it's already been adjusted. Go back to the Ollama website and open the page for the model you're working with. In my case, MFDoom Deepseek R1. Again, select the version you downloaded. Once you've selected the version, look for a section labeled params. Click on it to see the model's parameters. If you don't see anything labeled num_ctx followed by the context length, that means the model is still set to the default context length of 2048. Next, find out the maximum context length the model supports. To do this, go back to the main page for the model by clicking either the back arrow or the model name next to the params. Click on model and scroll down until you see the model name and the context length. For example, on my screen, it shows the model name as Gwen2 and the context length as 131,072. This is the maximum context length the model can handle. To make that number easier to work with, divide it by 1024. In this case, the result is 128,000. That maximum value might be too high for your system. Depending on your hardware, I'm working with 8 GB of VRAM and 18 GB of RAM, and I've found through testing that a context length of 8192 works best for my setup. It takes a little longer to run because of the processing happening in the background, but it provides a good balance of performance and speed. If your system has more VRAM or RAM, you might be able to go higher. If it has less, you'll need to experiment with smaller values to find what works. Once you've figured out the context length of the model and what works with your system specs, it's time to make the change. To start, create a new folder anywhere on your computer. You can name it whatever you want. For example, I've named mine New Ollama Model Files. Inside that folder, create a new text document. Open the text document and begin by typing the word from in all caps, followed by the name of the model you want to adjust. If you're unsure of the exact name, then go back to the command prompt you opened earlier and copy the name of the model. I'll copy the model name exactly as it appears, then go back to the text document and paste it right after from. On the next line in the text document, type parameter in all caps. Next to that, add num_ctx and set it to the new context length you want. For example, I'm setting mine to 8192. Once you've added that information, it's time to save the document. Click on File and choose Save As. In the dialog box, change the Save As type option to All Files. Then, give your file a simple, easy-to-remember name. I'm naming mine imif new deepseek.modelfile. After entering the name, click Save. That's it. The model file is ready to go, and you can close the text document. Next, navigate back to the folder where you just saved the model file. In the top navigation bar of the folder, type CMD and press Enter. This opens command prompt in that specific folder. In the command prompt window, type the following: Ollama create. After that, enter the name you want for your new model. You can name it whatever makes sense to you. For example, I'm naming mine MF Deepseek R1A1000 because it reflects the model and the context length I've chosen. After the model name, type -F and follow it with the name of the model file you just created. In my case, the full command looks like this. Press Enter to run the command. Ollama will process the file and create your new model. Once it's done, type Ollama list again into command prompt and press Enter. You should see your new model listed there, ready to use. To apply the changes, you need to completely close ComfyUI if it's running. After that, relaunch it by double-clicking the Run NVIDIA GPU.bat file. This step ensures that the new settings are fully picked up. Finally, let's talk about personas. These function similarly to Chat-GPT's custom GPTs, allowing you to use different instructions tailored for specific tasks. For example, you can set up a persona that specializes in creating image prompts, one that focuses solely on internet searches for relevant data or general knowledge, or even one designed for storytelling. Each persona is essentially a customized setup for how the AI responds, based on the job you need it to do. Here's how to create one. Start by opening a new tab in ComfyUI. Look for the input string node and the save persona node. These are the key components you'll need. Connect them together by linking the nodes. In the input string node, type in the specific instructions for your persona. For instance, if you want a persona to generate a list of the most current AI news, you might type something like this. You are an AI list generator. Your job is to search the internet and provide me with a list of the most current news about AI. The information should be as recent as possible. Formulate the list in a numbered format and include a small snippet explaining what each news item is about. Also, include the URL whenever possible. Avoid unnecessary details. Keep it straightforward. When I prompt with today's list, you will respond with a list of at least 10 items. Once you've written your instructions, move to the Save Persona node. Here, you'll need to give your persona a name. Replace the placeholder text where it says example with your chosen name. Something clear and descriptive, like AI News List Generator. After naming it, click the Q button. This will save it and store it in the custom node within the LLM node under Personas. To use this persona later, refresh the nodes in Comfy, then search for it in the Load Persona node. Once it appears, select it, and your custom persona will be ready to use. You can create as many as you want, each with their own unique instructions tailored to your needs. If you ever want to explore how an existing persona is set up, you can open it and review the configuration. This is a great way to learn more about how the system works and to fine-tune your own setups. Deepseek doesn't do well with system prompts or personas, so it's best to use them with other models only. You need to completely close and restart ComfyUI for changes to take effect. It can feel a little inconvenient, but it's worth noting so you don't get stuck wondering why your changes aren't showing up. This workflow, like the latent sync method we talked about before, is still experimental. Whether or not you decide to use it is entirely up to you. Thank you for staying this long, and please like and subscribe. It makes all of this worthwhile. Thank you again, and see you next time.